Hey everybody, it's Mr. Kimpton, and I'm here to talk to you about divergent boundaries. Divergent boundaries are where two plates are moving apart from each other. Okay, so here's what you need to know about divergent boundaries. These notes will come up on and off throughout this video, and they will also be available at the end of the video. Number one, plates move apart, as I just said. Number two, new crust is formed, primarily oceanic crust. 3. Divergent boundaries are located near rising asthenosphere areas. 4. Located mainly under oceans. 5. Often called seafloor spreading. 6. They create rifts on continents and ridges in oceans. And 7. They are a plate tectonic feature that spreads continents apart. All right, let's talk about why these plate boundaries work or how they work and how a divergent boundary causes continents to move apart. It really all starts with convection in the asthenosphere. The convection in the asthenosphere is what brings this hot material up and causes it to rise and break through the crust. This usually starts on a continent, which I'll talk about in a little bit, but as you can see in this diagram, you have two convection cells, and the upward movement of those cells is right next to each other. So it's going to be wicked hot there, hotter than if those two cells were not lined up in this way. Divergence is obviously in the center here above the word mantle, and so if you put that convection in motion, it's going to look like this. As I said earlier, most of these in Earth's history actually started out under continental crust. For example, Pangea uh, actually rifted apart, as we've talked about in class. The best example would be South America and Africa. There's a huge rift that actually formed and caused those two continents to actually, or that one continent to split apart, forming two continents. So in order for this to happen, you'd have to have a lot of heat. So two convection cells coming together and causing what is referred to as a mantle plume. So like a big plume of magma and heat, which weakens the crust. And this is already starting to try to rip apart the crust. So you have these forces that we call tensional forces. So pulling that crust apart, and the heat is rising, and that's going to cause it to actually break through and weaken. So if we were able to cut open the earth and be able to see that, it might look something like this. So as you can see, when you have your rift actually formed, you have a lot of faulting and the rock starts to slip down, and you also most likely have volcanoes where that magma is able to break through and release heat and liquid rock as lava. You can actually see the beginning of essentially an ocean floor forming. Now as that gets lower and lower, it'll fill up with water, and sometimes you get a chain of lakes, like the East African Rift System. And eventually, you could get a shallow sea that starts to go in there. As it gets wider and wider, bigger sea, bigger ocean. A great example of this is the formation of the Red Sea. Geologists are quite confident that this is how the sea formed, which is coincidentally, not coincidentally, but plate tectonically, it makes sense. It's right next to the East African Rift. So a sea like the Red Sea will soon be flowing into that. The Red Sea is between the Arabian Peninsula and East Africa and the Horn of Africa. And if you were to look at time, you would have a progression from the top picture here down to the bottom picture. So the beginning of rifting, significant rift valley, shallow sea, and then significant sea with actual mid-ocean or mid-sea ridge as there is today. Pretty cool stuff. I don't know about you, but being able to see things in motion usually makes me understand it a lot better. So let's go back to the beginning of the rift formation and then run it through all the way to making a shallow sea. So let's take a look at this. So here's where you would have that mantle plume and the convection helping to cause tension, and that rises and weakens the crust. And because of that weakening and lowering of the continental crust, we can see how a shallow sea would form and eventually a larger ocean as those continents are gradually moved further apart by the ridge system. So here are those steps all lined up in time, time going down in the picture, and you can kind of see the steps of how that would happen. So Pangea essentially was ripped apart by continental rifting, and slowly all these new continents were forming and then gradually moving across the world because of significant divergence in the oceans. It's pretty amazing stuff. And now let's take a look at your notes that I said we'd show again at the end. So if you haven't had any of this material put down, here's another chance to wrap it up. All graphics and multimedia that were actually in motion were supplied by the TASA Incorporated Multimedia CD-ROM, The Theory of Plate Tectonics. Written by Edward J. Tarbuck and Frederick K. Lutkins, Illinois Central College, illustrated by Dennis Tasa.